Welcome to the IoT's Smart Home Simulator build. By the end of this project, you will have a fully functional, tabletop-sized training panel, complete with a dedicated router, smart lighting, and an Echo Show interface. Think of this panel as a secure sandbox. It allows you to integrate devices, test automation routines, and practice network hardening on a closed system, entirely separated from a real home network. To build this, we need to combine three distinct disciplines. First, precision woodworking for the frame. Second, high-voltage electrical routing for the device power. And third, low-voltage network cabling to handle the data layer. Combining these physical and digital systems into one portable board gives technicians and advanced hobbyists a reliable, repeatable platform to master smart home technology. Step 1 is constructing the frame. We use standard 2x4 studs cut to your panel size. The thick lumber provides the structural rigidity needed to support repeated pressing, plugging, and component swapping. This diagram shows the required board preparation. Before making miter cuts, cut a 1/2-inch square notch along the inside length of every stud. Looking at the cross-section, this notch creates a continuous, flat ledge. Assemble the rectangle with this ledge facing inward. With the pieces arranged, pre-drill the corners to prevent the wood from splitting, and drive in 2.5-inch screws. Then drop your 1/2-inch drywall sheet directly onto that recessed inner ledge and screw it down firmly into the wood. Resting the drywall inside the frame instead of placing it on top completely encloses the fragile gypsum edges. This prevents the corners from chipping when the board is moved around the classroom or workshop. Once built, we move to component layout. This schematic shows the tape-first strategy. Tape the device boxes and cover plates to the drywall to verify visual balance from the front, and check that clamps won't collide behind the board. Keep all components at least 2 inches away from the frame rails and the bottom legs. Cutting too close to the edge compromises drywall strength and leaves no room for mounting hardware. Here is the 4-step cutout sequence. First, trace the box outline. Second, drill pilot holes inside the waist area. Third, cut along the line. And finally, insert the box for a test fit, checking that the cover plate completely hides the cut edge. When making the cuts, use an oscillating tool to plunge the blade straight into the drywall, slightly inside your traced line. Work slowly toward the corners so you don't accidentally overcut the boundaries. Always cut slightly tight at first. You can shave down the high spots with a utility knife until the box slides in snugly. A precise, friction-fit opening ensures the outlets and switches won't flex or wobble when you plug in devices later. We are now moving to electrical wiring. Keep the main power strip unplugged from the wall. Absolutely no power should flow through this panel until every box is covered, strain relief is applied, and an instructor or qualified electrician passes the final inspection. This diagram details our electrical route. We run Romax wire from the power strip plug adapter into the first outlet box. From there, the power continues down the line to the first round light box, and finally terminates at the second round light box. To wire devices safely, match the conductor colors to terminal types shown here. Connect the black hot wire to the gold screw, connect the white neutral wire to the silver screw, and attach the bare copper wire to the green grounding screw. Here is how that looks inside the first outlet box. The incoming power and the outgoing leg are both connected to the receptacle terminals. This bridges the connection, carrying the hot, neutral, and ground paths forward to illuminate the 2 light sockets. Running power strictly along this single daisy chain path keeps all the high-voltage wiring localized. This leaves our second single-gang box completely free of line voltage, creating a safe, isolated space for the low-voltage network cables. Moving to the back of the panel, we install the physical data layer. Mount the router and the patch panel securely to the drywall. Ensure you leave enough clearance below them to route your CAT cables without pinching the wires. This networking map shows our required connections. Run patch cables from the router's ports directly into ports 1 through 5 on the patch panel. Punch down cables from panel ports 7 and 8, running them to the 2 keystone jacks in our isolated data box. This chart details the T568B color order. When terminating your RJ45 ends in keystones, you must use a single consistent standard. Follow this exact left-to-right sequence, starting with white-orange, for every single punch down and crimp on the board. Once the cables are punched down, plug a network cable tester into each run.
send a signal through the line to verify continuity across all 8 pins in sequential order. A pass here confirms no crossed or broken wires. Locking in a clean, perfectly terminated physical network is the only way to guarantee that when the Echo Show sends a command, the target device actually receives it. Now we configure the router. This chart outlines the necessary setup flow. Always begin with a hard factory reset to clear any previous configurations. Log in via a wired connection and immediately update the router's firmware to the latest manufacturer version. This profile shows our wireless architecture using 2 separate SSIDs. The Smart Home Admin Network is reserved for trusted devices like your setup laptop and phone. The IoT Devices Network is broadcast on a 2.4 GHz band to ensure compatibility with smart plugs and sensors. As shown in the workflow diagram, you can now build the control layer. First, connect the Echo Show to the admin network. Then, use the Alexa app on your phone to discover and link the specific third-party vendor apps controlling your lights and thermostats. Once the accounts are linked, execute a functional test. Use the touchscreen on the Echo Show, and then use your voice to toggle the smart outlets and adjust the lighting modules on the board. With the hardware secured, the wiring inspected, and the data layer cleanly mapped, this panel is now a professional-grade testing environment, fully prepared for the next phase of HVAC integration and advanced security lab work.